Hey, Sean's here, and this will be my solution to task 11 for the RHCSA lab. Now, this is a bit more of an involved lab, and the way I chose to do it, since it's a lot going into just even this simple script, I would highly recommend you watch the previous video I made talking about managing users and groups in Red Hat Enterprise Linux 9. It's kind of also distro agnostic. It's not entirely specific to just Red Hat, so if you are familiar with other distros, this will still be applicable for even those. Now, because we haven't really touched shell scripting very much at all until this point, I've made this script very simple. It's not very efficient or scalable. I come from a programming background, so this is not like the way I did this was very brute forcey, not the way I would have done it, but I did it this way to make it kind of as simple as possible while still including some error handling. In an enterprise environment, the way the script is set up, you could use this would still work, but it would need a lot more refinement to be generally more useful. I wouldn't use, like, if I had to do something like quick and dirty, I would use a script like this, but if I had time to clean it up, I would definitely include a lot more error handling, exit codes, more guard clauses, and generally reduce the amount of redundancies we're using here. Use some data structures that would enable that, and overall make the script more portable. But again, like I said, the intent here is not to show you any advanced scripting tactics, it's to get you on the ground floor running, show you kind of what a script looks like, how to create them, and some basic high level concepts and fundamentals that you can use here. So we'll go ahead, and what we'll be doing in this video mainly is just walking through the script, explaining each step, exploring the thought process behind it, and also talking a little bit about what we could have done better. And that'll be most of the video, and then once it's done, I'll show you how to make the script executable, run it, and then show you the results of it to show you that the solution is indeed completed. Now, I first want to start off with this first line. It's a little bit of a sticking point, but it actually is kind of important. So this first line is referred to as the shebang, usually indicated by these characters here, the hashtag and then the exclamation point. Then afterwards, we are indicating the location of the shell program that we wish to use. Now, more beginner friendly, I would say advice would be to use /bin/bash, but I'm using obviously user sbin environment bash here. And why is that? Well, this is a more modern, I would say an updated approach to the shebang. The reason we're using this is because obviously you can see here we'll be accessing the environment variable version of bash. So to kind of simplify that explanation, so essentially based on the different servers you might come across, you know, on different Unix-like operating systems, you might not always have bash installed where you assume it would be, right, in the /bin/bash directory, right? It could be somewhere else, or you know, the user might have installed a different version than what you're expecting to find. So by doing it this way, we're going to be looking in the environment variables, looking for the first instance of the, you know, bash shell here as we've defined here, and you can of course change that to other different shells. There's a ton of different shells out there. And again, what this does is just make it so that we can actually, you know, execute that script. And if there's also environment variables that are relied upon in the script, we'll already be looking, of course, in that environment variable container to actually locate the shell script, so that will make it even better. So this is all about portability and redundancy essentially. So I highly recommend you just always use this. It does add some overhead to the script, slows it down a tiny bit, but it's very negligible, and it's just better overall to have this kind of safety fallback for your shebang instead of using /bin/bash. But you know, if you're making like simple scripts on your, like, I don't know, your Bluetooth desktop, for example, just your like daily driver, of course, feel free to use whatever you want, doesn't really matter. But I would say in an enterprise environment, always use this shebang instead. So moving on from that, let's talk about this first function here, create users. So again, elegance is not really our goal here. We're just trying to make sure that this works. So I think probably the worst function is definitely the add user to group function, since it's literally just verbatim, essentially doing the exact commands we would do outside. So it's a bit ugly there, but this first function's okay. Like I said, I didn't really put much thought into them. I wanted to keep them as simple as possible to kind of explain what's going on here. So the first thing you want to know, of course, is variable declaration. If you don't come from a programming background, this might be a little bit weird at first, but I hope I can explain it, as simple as possible. So essentially, a variable is just a value, or rather a kind of container for any value you want to put in there. And there are ways to specify the types of values that you want to put in, but that's outside the scope of this. Again, we're keeping it as simple as possible. So I create the variable base underscore UID here, and we're using camel case for that. That's, again, it's outside the scope, but it's good practice to use underscores instead of spaces. And you actually can't even use spaces in the declaration of variables, actually. So when you're doing variables in multiple words, you generally want to use an underscore or a hyphen, I would say, is the standard nomenclature, or you would want to concatenate that white space and keep it all in one word, essentially. So like you might want to have to do like base, no space, and then UID, and you would probably capitalize the first letter as well to kind of make it a bit easier to read, but again, outside the scope of this video. So you can see here that this variable base UID equals 1010. That's of course been assigned the variable 1010. So anytime you see the words base UID, that essentially represents that value of 1010. Same thing here, we have an increment variable that's being initialized, and we're setting that equal to 0. Now, as far as variable naming schemes go, you generally want to make sure that they provide as much information at a glance as possible. Don't be too wordy, but you should generally be able to tell what a variable is used for just based on looking at it, right? I name it base underscore UID here to indicate that this is the base UID value that we are going to be incrementing in the for loop that's coming up. And we have an increment variable to indicate, of course, that this is the value that's going to be incremented with each loop. That way we can change the base UID value within each loop as needed. Now let's talk about the for loop here. So we have this for loop here. So the structure generally for a for loop, there's a bunch of different ways you can do it. For our purposes, again, I'm going to keep it simple. This is not a very scalable way of doing a for loop declaration, but again, keeping it simple as possible. So essentially the declaration starts with the word for, then you're going to basically use the variable that's going to hold the place of the values after the word in here. So for user, we're using user because, again, in that variable naming scheme, we want to make sure that it's as clear as possible. So we know that every time this loop iterates, that user variable is going to change from the start of the values after the word, again, in. So in the first loop, the user variable is going to hold the value many. In the second loop, the user variable is going to hold the value mo, because it's second in that little list we have here defined after the word in. Third loop, user equals Jack. Fourth loop, user equals Marcia. Fifth loop, user equals Jan. Sixth loop, user equals Cindy. Then, after that declaration, we use a semicolon to indicate that that is done. The next keyword that must be used after that semicolon, and must again be used, is the keyword do. Now, for our purposes, after that, that's pretty much everything that's done for the for loop related syntax right now. Now we're moving on to what we actually want this loop to do with each iteration. So again, going back to that video that I made detailing the different commands and ways you can manipulate file permissions, users, and groups, we're going to use the user add command. We're going to use that with the -d option. What the -d option does is specifies a home directory for the user that we're making. So of course we're going to use that mount Autofs, and then we are using that variable made in the for loop again of user. And whenever you call that variable, whenever you want to use it again somewhere in your function or in the script, you need to make sure that you first started off with the $. That indicates that we are about to call a variable essentially to your operating system. And then you don't need to do this, but I would always recommend doing so. It just makes it more I think, in my opinion, makes it visually easier to understand when a variable is being called or whatever, and also just makes it, easier for other people. I recommend enclosing the name within curly braces. Again, you don't have to do it, but I think it's good practice to do so. Now that we have declared that directory, that home directory, and again, if you remember the Autofs service, as soon as the system tries to assign the user that directory, it's going to mount it automatically. They'll be able to access it just as if it was actually a persistent directory on the machine. Then we're going over to the -u flag, and if you remember, that's to specify a user ID. Now, of course, we're going to use the $sign variable to, again, declare that we're calling a variable name here. And then this time, because we're performing an operation on this variable, we're going to use 2 parentheses. Now that we are within the operation context, we're going to use the name of the variables, base UID, and we can also use the other variable name without even having to use an additional $sign to, again, signal that we're calling another variable. It just knows that your shell session essentially just knows that anything within these two parentheses are variables if you're using any actual names. So we're showing that we are basically incrementing that base ID by the value of the increment variable. If you remember, before we started this loop, it started at 0. So essentially we're just doing 1010 plus 0 right now. So it doesn't increment at all, and it'll correctly assign Manny the base UI, or rather the user ID of 1010. Now we, again, close that operation. It's done. We exit that context, and then we provide the last parameter to the user add command, which is, again, the name of the user. And again, since this is the first iteration, right now we're just specifying that this would be Manny, because again, the user variable, every single loop will change based on the values after that in keyword. So again, user in this iteration of the loop, this first iteration, will be equivalent to Manny. Now we put a semicolon to indicate that that command is done, but we are still within the for loop right now. So we're still looping over and over right now. But again, we're not done with this iteration. We want to do one more thing before we leave this first loop. We are going to increment the value of the increment variable by 1, and you can do that by enclosing it again within those double parentheses to show that this is an operation being performed on that variable. And you don't even need to use the $sign here. You could, but no need to. I think we've already clarified that this is, again, a variable. And then we will use ++ to indicate that it is gaining in value by 1. And then after that, we will include a new line just for clarity's sake. Use the keyword done. The keyword done indicates that we have reached the end of the loop and that we will be now going back over. So again, this for loop will run until it reaches Cindy, does all the commands related to Cindy, and then it will exit after that. Now, could this for loop itself have been better? Yeah, we could have done some other things to make this better. We could have even made this all one line instead of making this, 2 separate lines. We could have cleaned this part up where we're actually hard coding in the names. There's a lot of things we can do, and we also would probably like some error handling, error checking, just in case we try to do some operations that aren't actually logically consistent with the structure of our system. Again, the idea here is not to add those error handling and exit statusing code, stuff like that. We'd probably like some guard clauses here as well. Again, when you run scripts, especially scripts that will be doing low-level tasks and doing things like adding groups and users, you want to provide as many safeguards in as possible to protect your system from accidentally, creating undefined behavior. But again, like I said, that's outside the scope of this task and solution, so I'm not going to go too into that. There are resources I can recommend for improving. There's a bunch of textbooks. I'll link them in the description down below so that you can take a look at them if you feel that you need additional help on this topic, or you can ask me, if there's any questions about certain things. I'll be happy to answer them in the comments below. Now, with that done, let's move on to the next function here. So this is the create groups function. does pretty much what you expect. Again, when you create these functions and your variable names, you want to be as clear as possible in what they're doing. And actually, because I forgot to talk about it very briefly, whenever you're initializing a function or declaring a function, you're basically using, there's some different ways you can do it. I just like this way, it just looks cleaner to me. It's just personal preference. But essentially you are stating the name of the function, you do the parentheses pairing, where you have the open parentheses and the closing parentheses. You have to include a white space after that. Then you do the curly braces, and then everything within that function is included between the curly braces. Essentially, you need to make sure that you provide that closing curly brace, otherwise the function will essentially be open, and it will of course never complete its task, and you can't really call upon it because it's, you know, undefined. So make sure you remember that. Now let's move on to the role of the function. Now let's move on to what the function actually does. So again, we're going to use another for loop just to, you know, automate some of the stuff for us so that we're not constantly having to type the same thing. And it's also just more fun to use a for loop. So I won't go through the entirety of the for loop structure again. I think we covered it pretty well in the last function. But again, just remember that it starts with the keyword for, then we are defining the variable name that will be changing to the values after the in keyword with every loop. So the first loop group, the group variable will be the value of dba underscore admin. The second loop, it'll be group equals dba underscore managers, and so on and so forth. Make sure you include that semicolon after the list of values. After the in keyword, make sure you include the do keyword. And then now we're also going to be including the if statement logic here. So what is an if statement? If you don't have any programming experience, an if statement is essentially just, you know, it's essentially asking the computer, if this is so, then do this. And then you can also include other things after that initial statement, like the else statement, where you can specify behavior to occur if the statement that you just compared to was not true. So a lot goes into that. Again, it's kind of out of the scope of this video to fully explain this, and I suggest that you look up supplemental reading if you are not completely familiar with this. This is a bit more, you know, not advanced topic, but you need a solid understanding of the if statement, definitely, when it comes to administering a system, and definitely for developing shell scripts. So we are going to be saying here if, and if you are, you know, used to, again, programming languages, this will be a little bit weird in the syntax because you're not going to be like enclosing with parentheses or curly braces or different brackets or anything. You can use brackets for something called guard clauses, but we're keeping it kind of simple, just making sure that it's very open and easy to understand. So we're going to include a little bit of a guard clause here. It's not a formal one, so we're going to be saying if, and we include the exclamation point, which is an operator essentially to say that the following will be the inverse value of what it would typically mean. So let's kind of read through it without including the exclamation point, and then I think that'll be the easiest way to understand what exactly is happening. So we're saying if the getEnt group command ran with the parameter of, again, the group variable. So let's say getEnt group dba underscore admin. If the value of that, and then we're using the redirect character here, the redirect file character here, to redirect that output to dev/null, which is essentially kind of like the trash bin. It is a file. It's a device file. Obviously, you can tell, and Unix and particularly Linux operating systems, everything is kind of designed around being a file. So this is kind of like your trash bin, essentially. So if that value gets redirected here, and we receive a standard error output, and that standard error output can be turned into essentially a standard output value, then we'll go ahead and use the group add command on the group variable that we have here, again, which is dba admin. So essentially what all that means is if we see that get ent group, again, DBA admin in this first iteration, is able to be essentially transferred to the trash bin, and things get transferred to the trash bin essentially when they fail to work. So basically what this if statement is saying here, without that exclamation point, if we're unable to find that group with the get ent group and then $sign group, if we're unable to get it, that means obviously that it doesn't exist, right? Because otherwise we would have received an error, then it doesn't exist. But remember, we have to invert that because we have the exclamation point. So essentially what this is checking is, again, it was saying originally that we wanted to check if it didn't exist. Now we are or rather if it did exist, because again, we would have our output redirected to the trash bin. Now that we are checking if it doesn't exist, then if it doesn't exist, then we will perform the group add $group command. And I know that's probably very confusing. Again, I try to keep it as simple as possible, but I think it's very important that you see an if statement and using inverting logic like this, and especially using file redirection, redirecting it to null. If this is very confusing to you, again, feel free to ask in the comments. I'll explain it more in depth as best as I can, explain each part of it, or even, take it to ChatGPT or something. Really try to understand this particular part, because I think this is definitely there's a lot of meat here and a lot you can learn from this particular part of this function. That's probably the most complicated, again, this entire script will get. I tried to keep it generally high level, except for this part, because I felt it was important for you to see something that would be in a more efficient and not modern, but more realistic script. This is something that you would probably see in there. Something like that, it would be filled with things like these. So, of course, after that, we called the else statement. If, of course, we weren't able to add the group because, it was already there, then we're going to say, hey, this group already exists. And then whenever we are ending the if statement, we're going to use the fi command, basically the reverse of if fi, to indicate that we have reached the end of the if statement. And then, of course, we're exiting the for loop with the done keyword. And then, again, we're closing that function with curly braces. All right, and lastly, if your brain still hasn't exploded by now, we are covering the last function, and I think this one will be much easier for you to understand. So we're calling it, of course, add user to group. Keep it as clear as possible. It's a little bit long, but it's kind of just under my kind of pet peeve range. So I wouldn't really make your function names much longer than this, but you can see here, it's very simple. We are essentially just kind of hard coding everything. We're just repeatedly calling the user mod command with the -a uppercase G command or option, and then we are including the groups that we want to add the user to in this comma separated format, and then the last parameter, of course, separated by white space, is the name of the user. And then we just repeat that all the way down until we are done and close it, and then that is it for all of the functions. Now, of course, so it's important to note that just because we created these functions doesn't mean they actually occurred. You have to actually call on the function to make it happen. Calling a function, calling a variable, and whatnot, referencing a variable, all of these are just different ways of saying, hey, I need you to do what you were made to do, essentially. So when I'm calling a function, I'm just saying, okay, I want the function to happen now. That's all that means. People also say invoking, other different terms for it, but just remember that calling a function just means you're making the function happen. You're telling the function, hey, I need you to do something, do what you're supposed to do right now. So all you have to do to call the functions is you just basically use its name without the parentheses, and that's it. So you'll say create users because we want that to happen first, create groups because we want that to happen second, and then add user to groups because we want that to happen third. Once you've done that, you can go ahead and, of course, if you're, you forgot how to exit Vim, you just, right quit, and then you're done. So now that that's done, I'll go ahead and show you how to make that script executable, because in actuality, just because you made a script, and Of course, you want to make sure that the name of the script is appended with the .sh to show that it is, a bash script. You can't just run the script after that. Just because you finished everything, you need to make it executable. And how you can do this, we might have gone over it already, but you use the chmod command with the +x option, and then you just specify the location of the script, the full path to it. So this, I've already made executable, but I'll run it again just so you can see. And then you can see now, this is the way to make sure that your script is executable. You can see it'll even be highlighted green to show that, but if you see these X's here, then you are good to go. And then lastly, just a short note, you see where it's located right now. This is generally where you want to keep your shell scripts. You want to keep them in the user local bin, and bin just stands for binaries. Just a nice general way I would say most people keep their scripts in here. You can put them anywhere really, but this is where, again, I would choose to put them. And you can also, if you choose, it's again a little bit out of the scope of this, but you can place it in certain spots to add it to your environment variables. That way you can directly call the script without having to run the bash command before it, or even having to do this before it, because this is obviously the only way to run the script right now. You'd have to do bash user local bin create users in groups.sh if you wanted to have it so where you could literally just type create users in groups.sh. Then you would need, of course, to make sure that you added it to the user bin and make sure that it was included in the environment variables. Since I already have it in there, I can actually just call it again directly. I've already placed it where I wanted to, and in this middle installation, that kind of looks for it looks in the user local bin directory first for the various commands that the system has built into it. So that's just why I can do that there. But now that we have made it executable, we'll go ahead and run it. I just want to make sure, because I think actually in this snapshot, so right now, I would recommend you take a snapshot too before you run the script, just to make sure. I think I forgot in this version. Yeah, let's go here. DBA managers, because I forgot this here. So we'll save that. And now all we need to do is run this script. Oh, I actually didn't add it to my thing. So I lied to you there. My bad. Create users and groups. You'll see it'll go ahead, run it through. And don't worry about the warnings here. They don't actually mean anything. So you can see now, if we go ahead and list everything in the user, or rather the mount, Autofs home, you'll see all those directories just got mounted and applied to those users that we have here. You can see if we get int group, you can see here at the bottom, we have all the groups that we wanted to make. All the users were made as well, assigned their user IDs that were required of us. And again, all the users are in their respective groups. And that's all the requirements of this script. Now, of course, the next task is task 12, and that's just to copy this script over to server 2. Oh, and one more thing, make sure, of course, before you run these scripts, you actually have your repo server up, because again, that's where you're mounting the directories from. So if you try to run the script and you see that it's not able to mount the directories, it's probably because you don't have your repo server up, or there's some issues with the networking that you had set up between it and that. So make sure you're able to, ping it first or whatever. So like, make sure you can do ping, is it RHCSA repo? Make sure you're able to do that. Otherwise, of course, you won't be able to mount the directories. Now we'll go ahead and, or rather, copy the files over. I need to actually start this up to be able to do that. And again, I would highly recommend you create a snapshot before you run that script. Just save yourself some headache, because it's a bit of a pain to like remove all those profiles and groups afterwards. But once this goes ahead, before it loads, we will go ahead and SCP the user local bin, their groups, over to root at CSA 9 over 2. Put it in the same spot, the local bin. with the same name. Let's just save. Okay, you can see it was sent over there. And if we the mod, I'm already fairly certain it's here, so I'm just gonna do that, and it's executable. And now of course we can go ahead and run it on here, local bin. Okay, and then you can see here everything is set up. So yep, works on here too. And that is the end of tasks 11 and 12. On to the next ones. Like always, make sure to like, comment, subscribe. Sean ZX here. See you the next one. Peace.